The third quantum number is the magnetic quantum number, or it is signified by m sub l, no, with curved letter L in its subscript. So why is that? Because it's associated to the second quantum number, and we'll realize in a bit why. Now, the magnetic quantum number, it describes the orientation in space. As I've mentioned a while ago, the shapes can be into the x-axis, y-axis, or z-axis. No? And the formula for the magnetic quantum number is negative L is less than or equal to n, and then less than or equal to positive L. No? So, let's try to understand that by looking at these images. We've learned just a while ago that there are possible orientation in shapes for each orbital. S being a sphere will only have one. P being a bow tie, no, or a connected two circular or oval shapes could have 3. D could have 5. F could have 7. No, this tells us the possible ML, no, or the possible magnetic quantum numbers. So let's use the first two sets to identify the third set using the formula or the third quantum number. So if n is 1, this is my first quantum number. Excuse me. So paulit-ulit nating babalikan. Sana all binabalikan. No. If n, pusuan natin kasi Valentine's. Shing. If n is 1, that's my first quantum number, n is 1, what would be my L? So L using the formula would be n minus 1. That would be L is less than or equal to 1 minus 1, which is L is just less than or equal to 0. Since bawal ang negative, that would be 0. No? And then, to get the ML, sabi dito sa formula, balikan lang natin, mabilis. The formula for ML is negative L. This is ML pala, I'm sorry. Ayan. The ML is, yan, negative L to L. Negative L to positive L, or less than, greater than siya sa negative L, pero less than siya sa positive L. So what do we mean by that? So we just simply copy 0, negative 0, 0, and positive 0. But since there's no such thing as negative 0 and positive 0, ML is just 0. Now we have the first three quantum numbers, 1, 0, and 0. Alright. So what if my n is 1, L is 0, ML is 0, this would be the location of my electron. No? It would be here. It would possibly be here. Now what if my n is 2? So again, I'll find first my L, no, or my angular momentum quantum number, L, that would be 2 minus 1. So wag kakalimutan tong less than or equal to 1 because it will give you 1. Now, L is less than or equal to 1. Eventually, namamali dito ang mga bata kasi hindi bini-break down ang possibilities. This could be, could possibly be 0 or 1. Now, so if L is 0, my ML, if my L is 0, so if my L is 0, my ML would be 0. That would be 2, 0, 0. And my electron would be located again in an orbital that is spherical. Nakukuha ba? Now, what if I use the other one? Now, if L is 1, this time, using the formula for ML, which is negative, or ML is greater than negative L, but less than positive L. So, if I use this formula, if my ML is 1, no, or if my L is 1, no, that would be negative 1, 0, 1. Now, these are the possible orientations of my orbitals. Now, it could be in the x-axis, it could be in the y-axis, or it could be in the z-axis, no, or vice versa, or the other way around. So, negative 1, 0, 1. These are the possible orientations. Now, later on, we'll find kung alin dito yung exact location. Kasi tatlong orientation to eh. But for the meantime, ito muna yung mga possibilities. Now, what if my n is 3? If my n is 3, of course, using the same formula, 2 minus 1, 3 minus 1, this will give me 2. And then, my L would be 0, 1, and then 2. So, if my L is 0, this would be the shape. Sana nakakasabay na. If my L is 1, this would be my possibilities, negative 1, 0, 1. Again, using the formula, negative L, ML is greater than this negative L but less than positive L. No? Or simply, kakopy mo lang to, then use the negative values and the values in between up to 1. Now, what if my L is 2? Now, if I use the 2, if it's 2, that's the d orbital, of course, that would be negative 2 up to positive 2. So, I will have negative 2, negative 1, 0, 1, 2, 1, 2, 3, 4, 5. That's 5 possible orientation. If my n is 4, I don't know if I need to still do it, but for the sake of example, it would be 4 minus 1. That would be 3. No? And that would be 0, 1, 2, and 3. So I have 4 possible values for L. No? If my L is 0, that would be 4, 0. My ML would be 0. If my L is negative 1, it could be 4, 1, and then pwedeng negative 1, pwedeng 0, pwedeng 1. Ang third quantum number ko, because these are possibilities. If my L is 2, my first quantum number is still 4, second quantum number now is 2, the angular momentum quantum number is 2, and the values could be negative 2, negative 1, 0, 1, 2, depending on where my electron would lie in these particular orientations. So, if it's 3, medyo mas madaming possibilities. That's 1, 2, 3, 4, 5, 6, 7. Now, I don't know if it's making sense already, but how do we use it? It will make sense after I introduce to you the last quantum number, or the spin quantum number, indicated by MS, or the spin, S for spin. It's the spin quantum number. It describes the spin for a given electron. They discovered that the electrons are either spinning upwards or spinning downwards. Now, when it's spin upwards, we indicate it by using positive 1/2 or negative 1/2. Or an arrow like this one, an upward arrow and a downward arrow. Take note that they also discovered that a single orbital can hold a maximum of 2 electrons and each must have an opposite spin. So, we will use now the idea of the spin quantum numbers. So, let's go back with our very first example. So, again, we are locating of the possible positions of an electron. So, if n is 1, my L would be, so, by repetition, we gain to master the knowledge or the topic. L is n minus 1. This is the formula for the angular momentum quantum number or the second quantum number. That would be, sorry, mali ito. 1 minus 1, that would be 0. So, 0. So, that's my second quantum number. First quantum number is 1. Second quantum number is 0. And I've already learned ML. That's negative L to L. So, since it's 0, my ML is also 0. Now, my MS has 2 possible values. Now, it could be positive 1/2 or negative 1/2. If we go back to the definition, after I write it, we'll go back to the definition. If we go back to the definition, the MS, a single orbital can hold a maximum of 2 electrons and each must have an opposite spin. So, meaning, in this number, my orbital is 0. And 0 corresponds to what shape or what orbital? It corresponds to S. Therefore, my MS, so if I'll put it in an illustration, not exact drawing. This is my orbital now. the S can contain two electrons, which is either spinning upwards, no, or spinning downwards. These are the possible electrons that can be located because each orbital can hold two. So here, there's an electron that is probably spinning upward, an electron that is spinning downward. And that is the reason why we have an S1 and an S2. Now, the S1 is the one that is moving upwards, and the S2 is the one that is spinning downwards. Now, hopefully it makes sense. Now, if I use positive 1/2 as my MS, no, amazingly, my S would just be S1. No? Why is that? According to Hans' rule, up spin muna palagi. We fill every orbital with half spin before we fill it with down spin. That's the Hans rule, HUNDS, Hans rule. And this one is already my set of quantum numbers, 1, 0, 0, 1/2. And surprisingly, this is just S1, diba? And if I place my N, that would be 1S1. And what is 1S1? That is my hydrogen. Now, the hydrogen atom in a sphere, in an orbital, sphere with one electron that is spinning upwards. Right? Now, what if, sir, negative, this becomes, so let me erase this. I don't know if this is making sense already, but hopefully you see how wonderful the electron configuration is, and these quantum numbers, how did they build the electron configuration? If I use negative 1/2, so that means that I have one electron spinning up, one electron spinning down. Therefore, I have two electrons here in this region. So these are just for illustration. It could be anywhere here. This is no longer a hydrogen, but now a helium, with this set of quantum numbers. Now, hopefully, that makes sense. Now, if N is 2, my L would be, yan, i-shortcut na natin kasi nakuha na natin kung paano i-compute. That would be L is N minus 2 at N minus 1. That would be 2. That would be 1, sorry. So, L could possibly be 0 and 1. Now, ulitin ko, using the formula, L is less than or equal to N minus 1. That would be 2 minus 1. So, that would be 1. So, it could be 0 and 1. So, if L is 0, that would be 2, 0, 0. 2, 0, 0. I have one orbital here. My MS here could either spinning upward. So, if it's spinning upward, that's positive 1/2. If it's spinning downward, that's negative 1/2. So, kung positive 1/2 yung spin, that's 2s1. So, what element is that? No, that's lithium. Hydrogen, helium, lithium. Tama. 2s1. Now, if it's spinning downward, negative 1/2, it would be another element. Now, with the quantum numbers 0, 0, 0 and negative 1/2. Now, if I go to 2, 1 or 2p, diba, these are just 0 and 1 corresponds to S and P. Now, if I have 2p, the reason why we have until 6 because of this MS rule. Now, we have 3 possible orientations of the orbital, and each orbital can hold 2 electrons. Therefore, I have 1, 2, 3, 4, 5, 6. Now, these are full arrows, pero pwede naman ganyan. So, 2p6. Familiar? Diba? This could be 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. All corresponds to a certain element. No? If I use different combination. No? If I use, say for instance, positive 1/2, no? It could tell, or it could point out to 3 different elements. It could be 2, 1, 1, negative 1. So, nandito siya. 2, 1, 1, 0. Nandito siya. 2, 1, 1, 1, nandito siya. So, it's 3 different elements. Kag negative naman, similar. No? So, we cannot have the same set of quantum numbers for different elements. So, if n is 3, the possibility might grow bigger. It could be 3, 0, 0, 0. And the ms will always be positive 1/2 or negative 1/2. And if we grow larger with energy level, the more possibilities for electrons or the location of electrons would be. That's why at 4, diba, we have 4s1, 4s2, 4p1 until 4p6. We have 4d10, no, because we have 1, 2, 3, 4, 5, which can hold 2 electron each. So that's 4d10. And then we have F, which can hold 1, 2, 3, 4, 5, 6, 7 orientation with 2 electrons per orientation or per orbital, making until F14. Diba? Hopefully, it's making sense right now. No? This is very, very wonderful. So, how can we use this in practice, no? In a problem? Diba? Kasi baka useless naman sir yung mga pinagsasabi mo, no? As I started the discussion, I was telling you that the quantum numbers will tell us where the electron might possibly be. At the same time, it could tell us the element, no, the electron configuration of the element, and eventually what element it is. No, it's like somewhat the code of a specific element. Say for instance 3D, no, without any numbers, no, or a superscript, no, a specific number of electron. So let's check comprehension. What is the n here? The n, of course, would be 3 because this is the main energy level. No? The numbers before the letters are the main energy level. So you simply copy n is 3. Now, what would be the L? So here, since I have a specific, I just need to recall 0, 1, 2, 3. This corresponds to letters S, P, D, F. So, D is 2. So, my L is 2. And with that, I can possibly move forward. No, nandito pala yung sagot. So dito, if I'm asked, no, where is the electron? So I know that the electron configuration of hydrogen is 1s1. It can be seen in the periodic table, or you can do it by yourself. No, I've already taught you last sem. So by this information through the hydrogen image, I can get the first quantum number, which is 1. It is in n minus 1, which is 1. My second quantum number is 0, because s corresponds to 0. No? Para mas maintindihan, that would be 1s with possible orbital 0. That's 0. The labels are s for 0, 1 for p, or baliktad, 0 for S rather, 1P, 2 for D, and then 3 for F. Again, numbers are used to indicate letters. So 1, 0. Now, I only have 1 electron and 1 orbital, so it should be here. So the orbital is also 0 and the spin is positive 1/2. Alright, so these are my quantum numbers. So the quantum numbers, or the set of quantum numbers for hydrogen, is 1, 0, 0, positive 1/2. Alright? Hopefully, nakuha na. And you'll be able to pass, that particular door. So let's say you have an element, with an electron configuration of 1s2, 2s2, 2p3. Then what are the quantum numbers? If you are given the electron configuration, you only have to worry about the last electron configuration. That's 2p3. So basic n, you copy 2, L, you copy p. That's ulitin lang natin hanggang ma-master. 0 is S, 1 is P, 2 is D, 3 is F. DS, P, D, F, 0, 1, 2, 3. So if it's P, my L is 1, and then since I have possible values kapag ang L ko, I have 3 possible values for ML. ML could be negative 1, sorry. ML could be negative 1, it could be 0, it could be positive 1. So these are my possible orientation or orbitals for ML. So that's for my ML. I have 3 electrons, no? And I know by Hand's rule that would be spinning up muna, and spinning up. I know that the electron would land in the ML, which is 1. Na nakuha? So the quantum number is 1, and then it's spinning upwards. Therefore, my MS would be positive 1/2. Right, that's positive 1/2 for my 2p3. So this is the set of quantum numbers 2, 1, 1, 1/2. If you're curious kung anong element ito, just locate the electron for P3. That's 2 for 7th element, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. That's nitrogen. So nitrogen's address is 211 positive 1/2. If you tell it to a chemist, oh, I know that. That's quantum numbers. Alright, let's have another example. What element has this set of quantum numbers? So this time, it's different. It's the other way around. You are given a quantum number and you are to identify the element. So ano kaya ang element ito? Diba? Seemingly, ang hirap. Pero, let's just reconstruct the electron configuration. Or what we did a while ago, but the other way around. So 2 as my main energy level, because I know that this is the principal quantum number. This is the angular momentum quantum number. And I know that 1 corresponds to P, because paulit-ulit ko na siyang nilagay, that 0 is S, 2 is D, and 3 is F. So I know that this is 2P. But I know that P has 3 possible orientations kasi 1 siya. So it could be negative 1, 0, 1. And sabi dito, it lies on the 0 orientation. Nandito siya sa 0 orbital with a spinning positive 1/2. Or the only way for that to happen is that the first orbital should be filled with a spinning upward electron. So upward, and therefore I have 1, 2 electrons. That would be 2p2, and I can go back by adding the necessary electron configuration, or kahit hindi na, pero if trip mo, pwede 1s2, and that would be by counting the number of electrons 1, 2, 3, 4, 5, 6. I will know the atomic number because these are the same to proton, and I'll know the element. So 6, that's hydrogen, helium, lithium, beryllium, boron, carbon. That's the carbon, the element of life. That's how we use quantum numbers in identifying an element, or the other way around, element in identifying the quantum number. Sir, question, what if po ginamit ko, or namali ako, nakalimutan kong dapat upward spin muna palagi bago a downward spin. So what will happen if that's the case? If I have negative 1, 0, and then 1, say for instance, nakalimutan ko yung Hand's rule na dapat pinupuno muna ng upward arrows, or upward spin ng mga electron. So ito yung mangyayari. So I can write N, which is 2, that's still correct. 1, which is P, that's still correct. But I forgot that upspin muna. So ang mangyayari, trip ko, or baka trip mo lang talaga, downward muna, positive 1 up siya, so hindi pa, so downward, tapos pinuno muna ng upward, tapos tumama sa 0, positive 1 up, so eto na, I count the electron, 1, 2, 3, 4, 5, that's 2p5, and that would give you a different configuration and a different element. And that cannot be, now, because we only have one set of quantum numbers per one element. Alright. Sige. You may pause the video and try this one. What element is this one? Alright, hopefully you've tried it or you've paused the video. Similar, N is 7. Pwede mo tong lagyan ng mga label kung nalilito ka. N is 7, L is 1, ML is 1, MS is negative 1. So 7, that would be 1 is P, 7P. And then it lies a downward electron, a spinning electron with a downward motion stops at the first orbital. So that would be, since P, that would be negative 1, 0, 1. So, meron daw downwards ditong electron. So, pwedeng unahin mo na yon or pwedeng mag-umpisa kang 1, 2, 3, 4, 5, dito pala, dito sa 1, kasi nandito, 6. So, that's 7p6. And if you trace this in the periodic table, or if you continue the electron configuration, if you want it, pero ang haba, that's the 118th element, that's oganesson. Alright? We can identify the element using the set of quantum numbers by locating their electrons or how many electrons there are or there is, or by their position, we can identify the number of protons, the atomic number, and the element itself. Now, a lot of information can be derived from this particular quantum numbers. So, for your task, no, give the quantum numbers of NE. That's task number 1. I'll be writing it in the Google form. Second task, no, determine the electron configuration and the element for the set of quantum numbers for these 5 particular items. Alright? So, ang ilalagay nyo lang, hindi naman yung buong periodic table, I mean buong electron configuration, but the last, no, halimbawa 3p6, 4d5, etc., etc., yung last electron configuration lang, and then the name or at least the chemical symbol of the element. So there you have it, mga Chimek. Now, hopefully you've learned something for today. If you have any question, you may email me or send me a message via Google Chat or Messenger. That's it for today. Thank you and have a great day. Happy Valentine's Day. Peace out.